Welcome, fellow humans. This is the first video in a short introductory series that I call All the Logic Needed for Logic Games. And the focus in this series is not comprehensive, it's just to provide you with a quick guide strategy for applying logical principles quickly and accurately on the logic games portion of the LSAT. So what I'm going to do is provide you with a quick guide and a memorization strategy up front. Then I'm going to explain the reasoning behind the choices that I made and why we do it that way. I would encourage you to pay attention to the reasoning. I would encourage you to watch it. However, it's not necessary. All you have to do is memorize the quick guide, apply it on the LSAT. I think it's good for you to study the reasoning behind it, but it isn't necessary. In this first video of the series, we're going to talk about the conditional and the contrapositive, and hopefully we're going to make this a little bit easier for you. A conditional relation is any statement that employs some version of if-then. So for instance, I might have a statement like, if this figure is a square, then it has four sides. Or, if this is a cat, then it is a mammal. And in both of those cases, we're connecting two things together. If the figure is a square, then on the basis of that, it has to have this outcome, that it has four sides. If it's a cat, it has to have this outcome, that it's a mammal. Now let's go ahead and take our second example. If this is a cat, then it is a mammal. And let's go ahead and symbolize it. And we're going to symbolize it like this. The arrow here indicates that we're employing a conditional. So C arrow M says, C, if C, then M. Now to take the contrapositive, it works like this. Simply reverse your two terms. So C here is the antecedent, we move it over, we make it the consequent. M is the consequent, we move it over and make it the antecedent. But all we do is just switch the terms. And once we've done that, we negate each one of them. C becomes not C, M becomes not M. And we're done. This second expression is what we call the contrapositive. And that's it. That's how you do it. Now when you're diagramming this on the LSAT, I want you to stack the conditional on top of its contrapositive. Put the contrapositive, in other words, right underneath that original conditional when you're diagramming this on the LSAT. And I'm going to explain why when we turn to the reasoning portion of this, which we're going to do now. A conditional expression establishes a relationship between two things. In this case, cats represented by C and mammals represented by M. And I'm using these circles because we call this in logic a Venn diagram, and it's named after the guy, Venn, who invented this. So, okay, a conditional just says that there's a relationship between two things. In this case, cats, which we express by C, and mammals, which we express by M. And the relation that obtains is such that if C is the case, then M is the case. And when we use circles to express this, this C circle says this is the set of all things that are cats, and this M circle is the set of all things that are mammals. And of course, they have to overlap, and where they overlap, right there in the middle, that's where if C then M can be represented. Because the only place that we can locate cats is here in this overlap place where it's also M. So if there's a C, it has to be here in this middle area where it overlaps with M, because if it's a cat, then it's a mammal. So if it is a cat, it's got to go here where it overlaps with mammals to express that conditional. Now let's explore this a little more. So this is our conditional right here, this blue area in the middle. That says if it's a cat, then it's a mammal. So one question we could ask is, can it be a cat over here, outside of the overlap? And of course the answer is no, because that would mean that it's a cat, but it's not a mammal. And that violates the rule of the conditional, which tells us if it's a cat, then it's a mammal. So we can't have a cat over here outside of the circle of mammals, because then the conditional would be violated. And now let's look at the other side. Can we have a mammal, but a mammal that's outside of the circle of cats? Well, of course. Cats aren't the only mammals. There are many other mammals in addition to cats. So it can be true logically that out here we could have a mammal even though it doesn't overlap with the circle of cats. Because while we cannot have a cat that isn't also a mammal, we certainly can have a mammal that's not a cat. So let's now consider another option. Suppose that there were no mammals. So I'm going to black out this entire circle of the set of mammals. And this says there are no mammals. No mammals at all. And the question we could ask is, if we take away the set of all mammals, can we have a cat? And the answer is no. Because remember, this X over here says we can't have a cat that's not also a mammal. If it's a cat, it's a mammal. If we were to take away all mammals, we've taken away all cats as well. Because this colored overlap portion is now erased. And that's the only place where a cat could be, is if it's a, if it's a cat, it's a mammal. Take away the set of all mammals, can't have a cat either. And that's the explanation for the contrapositive. How? Well, let's look at our original conditional again. If C, then M. And what did I tell you to do? I told you to go ahead and reverse M and C. So M is the consequent, move it over to the antecedent. C is the antecedent, just move it over to the consequent, negate both, form the conditional again, and we have the contrapositive. And let's see if that matches up with our diagram here. Yes, of course, if it's C, then it's M. And remember, it has to go here in this little colored portion. That's the overlap. That's what tells us that if it's a cat, it's a mammal. Now let's look at the one down here. If it's not a mammal, okay, we go back and color in this entire circle of mammals. We black it out, no mammals. Then it's also not a cat, which makes sense because if this original conditional is true, if it's a cat, it's a mammal, then when you take away its ability to be a mammal, can't have a cat either. And these are the same logically. So if it's a cat, then it's a mammal is logically identical to if it's not a mammal, then it's not a cat. Now, I've chosen an example where it's intuitively clear how that works, right? Because we know, for instance, that cats are mammals. So if it is a cat, then it's a mammal. We also know that there are many other mammals that are not cats. And so it's very easy to see the logic here, but it applies no matter what. Anytime you're given a conditional and you want the contrapositive, simply reverse the terms, negate those terms, make a new conditional out of that. And that's the contrapositive. Just that simple. You don't need to have followed any of the reasoning I've gone through here. That's all you have to do. And now we're going to add one more thing. Remember, I told you to stack the conditionals so that the original conditional is directly above the contrapositive. Or if you prefer, the contrapositive is immediately underneath the original conditional. Why did I have you do that? Because it allows us to visually represent something that's true about conditionals, but that sometimes in the hurry of an LSAT we forget. And here's the simple truth that I mean. Everything on the left side, C and not M, those can't be together. And that's obvious, right? If it's a cat, then it's a mammal. So it could never be true that it's a cat and it's not a mammal. So everything on the left side here, that can't be true. I'm putting a little X above that because those two can't be true together. However, everything on the right side can be true together. And remember, this expresses what we saw earlier. It can be a mammal, but not a cat, because there are mammals that are not cats. And when you stack the conditional and the contrapositive this way, it's just an easy visual reminder. What's on the left can't be together. What's on the right can be together. And just like that, you've got all the implications you need to have from that one conditional. You've got the contrapositive, and you've got the recognition of the two that can go together and the two that can't. So let's look at this with something that resembles an LSAT rule. Suppose I were to say if R is third, then T is fifth. And we would represent that like this. And of course, we know how to take our contrapositive. We reverse, we negate, draw a new conditional, and that's it. And I've put the contrapositive directly beneath the original conditional so that if R is third, then T is fifth. If T is not fifth, then R is not third. And so on the left side, we draw an X. Those two things can't go together. On the right side, here's a check mark. Those two things can go together. If we were to visualize what these look like, we would put those over here to the right so that the initial conditional would look like this. The contrapositive might look like this. And knowing that these two can be together, we might represent that down here like this, And finally, let's say a word about logical negation. Logical negation is not like mathematical negation. It's not like other types of negation. Because in logic, negation simply changes the truth value of whatever expression we're negating. And one easy way to think of that is that it's like a light switch being turned on and turned off. So if we have something positive, let's say P, then when we negate it, it becomes negative, it becomes not P, and of course it goes in the reverse. If we negate not P, then it goes back to being P. It's just like a light switch. It's turned on, it's turned off. So we have P, then we have its negation, which is not P, but the negation of not P goes back to being P. And it just alternates back and forth like that. So suppose we had the following conditional. If not R, then S. And what do? We reverse. So S gets moved to the front. R gets moved to the back. Now R is already negated. So we negate the negation, make it positive. Not R becomes R. S, which is positive, is negated, becomes negative, is not S. And that's it. So just remember that negation in logic just switches things back and forth. P, not P, not P, over and over like that. And you'll be good to go. Now that's the quick guide. That's the reasoning for the quick guide. I have attached some exercises for you to practice with on the website. I also provide an answer key. However, do not look at the answer key until you have tried your best to work all of the problems that I've given you. Have fun and keep watching.